In this example, we're going to discuss how to find the A inverse of order 3 cross 3 by using E-column transformation. So this is the A matrix of order 3 cross 3. First, we need to find the determinant of A, that is 1 minus 25 minus 3 into minus 10 minus 2 into minus 15 will get 25, which is not equal to 0. Therefore, A inverse exists. And we have already discussed the magic pattern to find out the A inverse. So what it is, it's something like this. So this is the magic pattern now we're going to follow to find the inverse. So our first step is to write A is equal to A into I. Now the next step is to convert this element as 1, but it is already as 1. So next element is this. Now we need to convert this as 0. So how to do that? It is column 2 changes as column 2 minus 3 times of column 1, because when we do that, the 3 changes to 3 minus 3 times of its corresponding C1 element and becomes 0. Here C1 and C3 elements remain as it is, only C2 elements changes as 0, and here it becomes 9, and here it minus 1. Next, here it becomes minus 3 and 1, and 0 remains as it is. Now, we need to convert a 1, 3 element, that is minus 2 to 0. So how to do this? Now we can write C3 as C3 plus 2C1, because when we do it, minus 2 changes as minus 2 plus 2 times of its corresponding C1 element, that is 1, and gives us 0. Now, C1 and C2 elements remain as it is, only C3 elements changes as 0, and here it becomes minus 11 and 4, here 2, 0 and 1. Now, our next step is to convert this element as 1. So, how to do that? Just divide it by 9 itself, because when you divide it by 9, you will get as 1. Now, C1 and C3 elements remain as it is, only C2 elements changes as 0, 1 and minus 1 by 9. Here it becomes minus 1 by 3, 1 by 9 and 0. Next step is to convert this entry as 0. So to do this, we'll write column 3 changes as column 3 plus 11 times of column 2. Because when we do that, minus 11 changes as minus 11 plus 11 into its corresponding C2 element, that is 1, and becomes 0. Now here C1 and C2 elements remain as it is, only C3 elements changes as 0, 0, and here it becomes 25 by 9. Here it becomes minus 5 by 3 and 11 by 9 and 1. Now our target is to convert this 25 by 9 as 1. So to do that, just again divide it by 9 by 25. Because when you do that, 25 by 9 changes as 9 by 25 into 25 by 9 and gives us 1. Again, C1 and C2 elements remain as it is, only C3 elements changes as 0, 0 and 1. And here it becomes minus 3 by 5, 11 by 25 and 9 by 25. Now, our next step is to convert this entry, that is minus 1 by 9 to 0. So how to do this? We can write column 2 changes as column 2 plus C3 by 9. When we do that, here it changes as minus 1 by 9, changes as minus 1 by 9 plus 1 by 9 and gives 0. Now C1 and C3 elements remain as it is, only C2 elements changes as 0, 1 and 0. And here it becomes minus 2 by 5. Here it becomes actually 36 by 25, but we can write it as 4 by 25, and here it is 1 by 25. Now next element is to convert this as 0. So to do that, we can write it as C1 changes as C1 minus 2 times of C3. When we do that, 2 changes as 2 minus 2 times of 1 and gives us 0. Here C2 and C3 elements remain as it is. Only C1 elements changes as 1 minus 3 and 0. Here it becomes 11 by 5 minus 22 by 25 and minus 18 by 25. Our next step is to convert the last step, that is minus 3 to 0. So to do that, C1 changes as C1 plus 3C2. When we do this, minus 3 changes as minus 3 plus 3 times of C2, that is 1, and gives 0. C2 and C3 elements remain as it is. Again, C2 and C3 elements remain as it is. Only C1 elements changes as 1, 0, and 0. And here it becomes 1 minus 2 by 5 and minus 3 by 5. So now we can observe here it is in the form of I is equal to A, and this is some matrix B. And from here we can write it as A inverse as B. Hence, A inverse is equal to 1 minus 2 by 5 minus 3 by 5 minus 2 by 5 minus 3 by 5, 4 by 25, 1 by 25, 11 by 25, and 9 by 25. This is the required A inverse for this question. But you can observe I've taken the same example which I've used for hero transformation, but you got the same answer. Hence, we can tell that or we can prove that whether you use hero transformation or e-column transformation for a matrix, you will end up getting a same answer. That is same inverse of the matrix.